So this is a continuation of the Trigonometric Identities videos, the series of videos that I'm putting out for 8.4. This top section, these 9 different identities, they're kind of definitions, all right? So the sine is opposite over hypotenuse, cosine adjacent over hypotenuse. So these are the identities or the definitions that you already know. The trig functions, and then their inverses, and then know that the inverse can be written in 2 different ways. One over the sine, one over cosine, one over tangent, or you can use them as the definitions like hypotenuse over opposite and hypotenuse over adjacent and adjacent over opposite, things like that. So when you're looking at using some of these identities, you're going to need to have a pretty good understanding of what the reciprocal relationships are with the original identities. Now, I wrote the Pythagorean identity here. There's 2 other Pythagorean identities I need you to know about. And the first one is based on the first Pythagorean identity. What I'm going to do in this case is if we took this and we divided everything by the cosine squared of theta, right? What I'm saying is I'm going to take this entire section and I'm going to divide it by the cosine squared theta. When I do that, what happens, right? So the cosine squared theta divided by cosine squared theta, that's just 1. Then the sine over the cosine, right? So we have the sine theta over cosine theta squared, because both of them are squared, I'm just going to put the squared out here, is equal to 1 over the cosine of theta squared. So the reason I changed those is because now I have the sine of theta over the cosine of theta, right? And the tangent is actually going to be the sine over cosine. So I can switch this back to 1 plus the tangent squared of theta is equal to 1 over the cosine, which is the secant squared of theta. So this next one is our second trigonometric identity that we're going to need for the homework. Okay, so, and then that's how you get them, right? 1 plus the tangent squared of theta is equal to the secant squared of theta. 1 plus the tangent squared of theta is equal to the secant squared of theta. So to get this identity, what we did was we divided by the cosine. The next identity that we're going to use is we're going to take the Pythagorean identity, the initial one, the very first one that we had, and now we're going to divide it by the sine squared of theta, and what do we get? So, get my marker. So the sine squared theta divided by the sine squared theta is equal to divided by the sine squared of theta. This becomes cosine over sine, and that's going to be the cotangent, or cosine theta over sine theta squared plus 1 is equal to 1 over the sine squared is going to be 1 over the sine squared of theta. Then cosine over sine is cotangent, okay? So that's going to say we're going to have the cotangent squared theta plus 1 is equal to 1 over the sine squared theta, which is going to be the cosecant squared. And then that's going to be our third trigonometric identity that we're going to use. So that's the cotangent squared theta plus 1 is equal to the cosecant squared theta. So in our algebraic manipulations, you're gonna have to keep in mind that out of these three identities, we can have a lot more, okay? There's a lot of different ways that we can write this identity, right? We can say the tangent squared of theta is equal to the secant squared of theta minus 1. Because we subtract 1 on both sides, so we're solving for tangent, right? Or if we go to the other side, we could say the secant 1 is equal to the secant squared theta minus the tangent squared theta, right? So we can write this identity in a couple different ways. So just understand that that's how we're going to have to imagine or identify these three Pythagorean identities. Now, how are we going to use them? How are we going to use them? That's going to be the subject for the next video. I just want to show you all three Pythagorean identities in this video. And our list here, right? So our sine of theta is equal to y. Our cosine theta is equal to x. Our tangent of theta is equal to y over x. And then this is also the sine of theta over the cosine of theta. When I was doing the tangent, right, I wanted to reference that, but I didn't have it written, but I'm going to write it now.